So hey everyone, welcome to Student Algorithms. So in this video we're going to discuss about the 6 major topics where we'll be covering about the check bit, set bit, clear bit, toggle bit, extract bit, count set bits. So first, what are this? So let's consider real world examples. Let's take a bunch of bulbs where the functionality of bulb is whether it should be on or whether it should be off, right? So if it is on, we'll be considering it as 1. If it is off, we'll be considering as 0. So let's consider this bulb as let's randomly give the numbers. Okay, this means it turn on, this means it turns off, this means it's turned on, this means it's turned on, this means it's turned off, right? So this is just we are relating the real world example. So check bit is nothing but we need to check whether this bit is turned on or off, whether this bit is turned on or off at particular position. We'll consider this as 0 position, 1 position, 2 position, 3 position and 4 position, right? At particular position, whether the number is 1 or 0, we'll be checking. So this is all about the check bit. Now what is set bit? No matter whether the bulb is on or off, we need to turn on the bulb. That means if we have 0 or 1, no matter we have 0 or 1, we need to convert that into 1. Set is nothing but 1, so that's why we need to set that bit into 1. We have seen that 1 is nothing but set, we'll be calling it as set, and 0 is nothing but unset, right? Now clear bit is nothing but we have turned on 1, right? Now we need to turn off the bulb, so for that we need to clear bit. So no matter what the bulb is turned on or off, we need to switch off the bulb. Getting? So if we have 1 or 0, we need to set that bit into 0 at particular position. So next, toggle bit. Toggling is nothing but toggling is nothing but, for suppose the bulb is on, we need to make it off, right? If it is off, we need to make it on. This is all about toggling. So toggling means we need to make it reverse, like if the bulb is on, we need to make it off, and if it is off, we need to make it on. That means if at particular position the bit is 1, then we need to make 0. If it is 0, we need to make it 1. We need to toggle it. Toggle is nothing but make it opposite, like if it is on, we need to make off, it is off, we need to make on, right? Now extract bit is nothing but what at such position we need to extract, we need to know whether the bulb is on or off. Like we have 1 0 1 1 0, right? So in this we need to know that at particular position, let's say my position I is equals to 4, we need to extract whether the bulb is on or off, whether the number is 0 or 1. So this is all about the extract bit. Count set bits and count unset bits is nothing but in the entire position. As we discussed, set is nothing but 1, right? So in this we need to check how many number of 1s are present. That means how many bulbs are on and how many bulbs are just working currently. So that's how we need to decide. We need to simply count the number of 1s in a particular number. So this is all about what we are going to discuss today. So now let's move into tip. So first thing, we need to check bit. Check bit is nothing but determine if the height bit 0 based from right. We need to give it from right to left, right? So in this way we need to give the numbers. So that's why I mentioned 0 based from right to left in a number is 1 or 0. That means let's consider some n value here. Okay, let's consider some n value over here. Let's consider n value as 5. Okay, so now we have 1s 0 1, right? So we need to determine if the ith bit 0 based from right in a number is 1 or 0. So we just need to we just need to know whether the number is 0 1 0 1. They didn't mention it should be from 0 or 1. So to travel from left to right, we need to use some shift operators. Either it might be left shift or either it may be right shift. So for traversing we are using one operator that is very clear. We need to operate from left or we need to operate from right. So this is all about check bit. Firstly what we need to do, as they are given, we need to check at particular position, we need to traverse it, right? So generally if you want to perform any operation, we'll be performing at 0th position, but if they say we need to perform at 1 position or 2 position, we need to shift. We need to perform over here or we need to perform over here. So for that, the left shift or right shift will be helpful. So how this left shift and right shift will be helpful? For suppose I have the number over here, I need to find I need to check the bit at 2nd position. So what I'm supposed to do is I need to shift n 2 times right. So that becomes, if I shift 1 time, that will become 0 1 0. If I shift 2 times, that will become 0 0 1. So the shifting is nothing but we need to shift how many times position, at what ith bit position. So that's why we'll be writing n right shift 1. I hope it's clear now. To check or to extract or whatever the operation we are going to perform at the ith bit, we need to traverse to that. It's a general thing, right? So that's why this is very important step. So now, okay, we traversed, we done everything. So I just got this number from 5. So how to check whether that number is 0 or 1, right? So for suppose I have the 0 0 1 over here, and then we need to check whether that number is 0 or 1. So how we are going to check? Which operator we are going to use? Okay, let's try first OR. Okay, I'll going to check with 1. So 1 or 1, that gives me 1 itself. If I'm going to check with 0 and 1, if you perform OR operation, it's give 1. It's insane, right? So instead of OR operation, OR operation, what we are going to do is we are going to try with AND operation. So firstly, n left shift 2. So what we got? 0 0 1. Try with one more operation, that is AND operation. So now so 1 and 1 gives you 1, and then 1 and 0 gives you 0. That means whenever you want to perform, we need to check whether the number is 0 or 1. We need to perform the AND operation and we can get that number, right? If you have this, we'll get 1, and if we have 0 over here, we'll be getting 0 over here. This is all about the check bit. Check bit is nothing but we need to traverse that number to the right high times, because we are checking at the ith bit position, and then we need to check with AND operator whether the given the bit position, the given bit is whether 0 or 1. This is all about the check bit. Now let's move into the code. So now in code, what we are doing, as we discussed, we are traversing this one. We can do it either ways. We can traverse it to the right or we can traverse it to the left. Okay, if you traverse it to the right, like we can directly perform, you know. If we traverse it to the left, what is the change is, if we traverse, we have 101, we need to check at position 2. So what we have done, we have traversed this 1 to the position 2 and we performed AND over here. So what we'll be getting 1 and 0 will be 0, and 0 and 0 will be 0, and then this 1 and 1 will be 1, right? So now if we perform 1 0 1 and then 1 0 0, what will be getting if we perform AND operation? So here 1, just a minute, I'll be doing here. So 1 and 0 will be 0, 1 and 0 will be 0, and 1 and 0 will be 0. This resulting you 0, right? So if I have and at that particular bit position, so if you have 1, it won't be 0, but if you perform the particular position with 0, it resulting to the 0. That's why if you perform the left shift, we will be checking n and that bit position. If it is not equals to 0, we need to print 1. If n and that bit position equals to 1, then we'll be printing 0. Okay, so this is all about the check bit. Check bit is nothing but we can do it in either of ways. We can shift it to the right and we can shift it to the left. So if we shift it to the left, we need to perform the AND operation over here, and we need to check whether the number is 0 or the number is not equals to 0. If it is not equals to 0, we need to print 1. If it is equals to 0, we need to print 0. This is as simple as that. Now we move on to the turn on. Turn on is nothing but, as we discussed, at particular position, like let's say 0 1 2, at particular position we need to change this bit into 1 no matter what. So as we discussed previously, what we have done, we need to shift this bit at ith position, 1 bit into ith position, right? After shifting that into ith position, and then what we supposed to do, we supposed to perform OR operation over here. That's what. So no matter if we have at least 1 1, I mean at least 1 in 1 comma 0, will be getting 1, right? That's why, you know, OR operation is best for it. So while choosing the operators, we need to make sure we need to perform the operation on different numbers like 101, 110, etc. So for that, to make it 1, to turn on the ith bit, or to make it 1, we need to check whether these operator will be working. We need to check AND operator works. No, it doesn't work, because if we have at least 1 0, it turns into 0. That means we cannot turn that particular bit into 1. So that's why the choosing of operators is very crucial over here. So now here inside bits, so what I'm supposed to do is, literally I'm just want to 1 0 1. Let's consider this first. I'm shifting the 1 to the left position, and then what I'm doing, I'm performing OR. So now I will be having 1 or 1 will be 1 0 and 1. If we want to perform over here, I need to shift that bit into that position. Let's consider we'll be shifted into one position, and then we need to perform the OR operation. We'll get 1 1 and then 1. Alright, so this is all about the setting bit. Set bit is very easy. At whatever position we are doing, what we're supposed to do, we're supposed to do OR position with that particular bit. Alright, now what we're supposed to do is, we're supposed to turn off the ith bit. Turn off the ith bit means we're supposed to what? We're supposed to turn it into 0. So turning it into 0 is, if we consider 101, we need to make this particular bit into 0, or if it is 0, we need to be let it be. We no need to change it into 1. That comes under toggle. But in clear bit is nothing but we are just clearing that bit. Clearing that bit means we are making it to 0. Alright, so now let's look into the code. So in this clear bit, what we are having is, we just shift into the left at ith position, like 1. Let's consider 2 over here. Let's consider first 3. So 1 0 1, we have 1 over here, and what we are performing is, this is very crucial. Okay, so now we need to supposed to negation, I mean we need to perform the negation over here, like we have 1 0 1, right? So now 1 over here position and 0 0, the position is in this way, right? So what we have to supposed to do is, we supposed to form the negation over here, like we'll be getting 0 1 1. If it is 32-bit, we always getting ones. So we need to perform negation over here. So then after performing the negation, so we need to perform AND operation. So in performing the AND operation, 191 will be 1, 190 will be 0, and then 190 will be 0. So in this way we need to ignore this bit, of course it will be getting 0 0 0. So what we are doing at third position, the bit is 1, then we need to convert it to 0. So first what we are doing, this is very important step. First we need to traverse that to the ith position, and then what we need to do, we need to negation it, I mean we need to make the bit toggle. If you have 1, we need to make 0, if you have 0, we need to make 1. So this is crucial step before performing AND operation. If you just directly perform AND operation, we will be it's just checking the bit, right? As we discussed over here, it is just checking the bit if you perform just normal AND operation. But we need to we need to perform negation operation, and we need to convert that 1 into 0 and 0 into 1. Then in that way we will be clearing the bits. Alright, now toggling the bit. Toggling the bit is very easy. We need to analyze what operator we will be using to toggle this bit. Like for suppose we have 1, and then we are making toggle, and we are converting it to 0. We have 0, we are making it toggle, and we are converting it into 1, right? So this is nothing but toggling the bit. We need to flip, if you have 1, we need to make it 0, if you have 0, we need to make it 1. This is nothing but toggling the bit. Okay, now we of course for traversing we need to perform left shift or right shift operators, anything works for to get the element at the ith position. But to make this 190 as 0 and 1, what we supposed to do, which operator we need to choose? AND operator? No, because if you have 1, it always results to 0. Majority it will be results to 0. If you have 1, it majorly if you use OR, it majorly results to 1. Then what we supposed to use? And what bitwise operators we have? We have XOR operator. Here the king comes. So XOR operator is nothing but if we perform 1 1, if you have same bits, it gives you 0. If you have different bits, it gives you 1. That means if you have 1 and we are performing with 1 operator, it automatically turns to 0. If you have 0 and we will be performing XOR operators with this one, that gives automatically 1. So we can conclude that in toggling bit we are using XOR operation. So this is simple. We need to shift the right, we need to left shift the ith bit, and what we used to perform is we need to just perform n is equals to n bit. Simple. And in n XOR bit is nothing but let's have 1 0 1. Let's consider at third position we are just performing the toggling bit operation. So what we supposed to do, we supposed to shift this 1 to the second position, at 0 based index 1 2. So now the 1, and then we need to perform XOR operation. So after performing XOR operation, what will be having? 1 XOR 0 will be 1. Yes, 0 XOR 0 will be 0, of course 0. Then 1 XOR 1 will be 0. So we got this. We have 1 which is converted into 0. Now we look at the scenario where 0 gets converted into 1. So now I'm shifted this into first position, and then I'm just trying to write over here. Then 1 XOR 0 will be 1. Then 0 XOR 1 will be 1, and 1 XOR 1 will be 1. So that means what we have done, we just converted 0 into 1 and then we converted 1 into 0, right? Toggling is happening, right? So this is what we'll be doing in toggle. Next, extract bit. Extract bit is nothing but we need to check the actual value of the ith bit, whether that will be 0 or 1. This is same as like get bit, as we discussed at the starting. So now in extract bit, what we're supposed to do is we're supposed to shift that element to the right, and then we're just performing AND operation over here. Like as we discussed, it is similar like check bit. As we discussed over check bit, but we are performing left operation, but in the extract bit we'll be performing the right operation and we'll be getting that number and we'll be storing it in the bit, and then we're just returning it. Like for suppose I have 101, whether I need to check whether at the second position from 0 based index whether the given bit is 1 or not. So for checking that whether the given bit is 1 or not, what we supposed to perform, we're supposed to perform AND operation after right shifting bit. How many times we need to shift right? One time, right? So high times, so that becomes 010 and that becomes 001. If you shift, it's 2 times, and then we need to perform AND operation, so that gives you 1. So in this way we need to do the extract bit operation. After that, count set bits. Count set bits is nothing but we need to count how many number of set bits are present in particular binary representation of number. For suppose let's take this number. How many set bits are there over here? We have 4 set bits. Set bit is nothing but 1, unset bit is nothing but 0. So the number of set bits this binary representation contains is 1, 2, 3, 4, right? So there are different methods to solve these count set bits methods. First is string method, second is bitwise method, and third is Brian Kernig's algorithm, and then inbuilt method. So now let's get into the step. So in count set bits method, what we are going to perform is we just convert this binary string. I mean, we'll be taking n and then we need to convert into binary string, and just we need to count how many numbers are there or not. I mean, for I suppose we have 13 over here, and just we are manually converting that 13 into binary number, and then after converting that into binary number, we just checking. We are just looping over entire string and we just checking whether that for suppose we consider this as some a. So whether that a of ai is 1 or not. Now let's move to the actual algorithm and coding part. So first what we are doing, just we need to convert that binary number into we just convert that binary number into the string, and then we are just looping over the string. Like we have 1 1 0 1. From starting we just loop over that string. If that character is 1, then we need to increment that count, right? So what we supposed to do is we just convert that into binary string. We need to loop over it 0 here 0 1 2 3. It is in string form, that's why we'll be indexing from left to right. So firstly what we have over here is if that character is 1, then we'll be counting this and incrementing the count. This is as simple as that. You try to code this, and then next we'll be moving to the bitwise operation. Bitwise operation is nothing but in check. We need to check this whether the last bit is 1 or not, and then we need to shift to the right. As we discussed in the extract bit, what we did in the extract bit, we just checked whether the given bit is 1 or not by performing the right shift operation, right? Same way, first what we are doing, we just initializing count equals to 0, and then when n is greater than 0, because we need to loop over the n bit. If it is we don't keep any condition, it will be moving to the infinite loop. Toward this infinite loop, the last point, the end point is 0, that's why we'll be considering this as while n is greater than 0. And then we have n 1 0 1 1, and we need to perform with AND operation. So we got 1, and then we need to right shift it, then 1 0 1 and then 1. So after performing AND operation, we got 1 over here. So what we are exactly trying to do is, first we need to check the last position. From last position we are coming. at last position whether the given set is 1 or not, we are going to check. After checking, if it is 1, we are incrementing count, and then we'll be performing right shift over here. After performing the right shift, what we are supposed to do, again we are checking the next bit until it comes to 0. After checking the next bit whether it is 1 or 0, if it is 0, we don't need to perform anything. If it is 1, again we need to increment the count. This is how it works. We need to shift the to the left how many times until n becomes 0, right? This makes sense, right? So this is all about bitwise method. Now Brian Kerrigan's method is nothing but I'm directly going to the code part. So what exactly happens over here is, first we need to take 13 equals to 1101, and then what we need to perform, AND operation with n minus 1. N minus 1 is nothing but 12, right? So if you perform AND operation over here, we'll get 1 1 0 0. We need to keep going until n equals to 0. Like, let's look into the code now. So for suppose we have count equals to 0, we have while n greater than 0, n is equals to n minus 1. Then count plus plus. For suppose n is equals to, however, n9 n minus 1. So in previously what we have, 1, let's take simple number, okay, 101, and then n minus 1 is nothing but 100. If we perform AND operation over here, what will be getting? 0, not 0, 1 0 and 0. We'll get 1 0 and 0. And then what we supposed to do, we need to increment that into 1. I'll be telling why we are supposed to do that. And then 1 0 0, and then 1 0 1 1. So now what is AND operation? AND operation is, it becomes, again we need to make n and n minus 1, right? Becomes 0 0 0. Got it? So basically what we supposed to do is, see, I'm trying to tell, we have seen n and n minus 1 in power of 2, right? So in that, what we are exactly saying is, the everything what we perform, that will be moving to the right. Like for suppose, let's consider this example. Wait, if you want to understand this, you need to understand this particular thing. Alright, so if you have n and n minus 1, if you have n is equals to, let's consider n equals to 8, and we have n minus 1 is equals to 7, so it gives you 0. That means whenever you will be performing any operation to power of 1, it turns into 0. This is pretty much clear. So now, I'm sorry, okay, now let's consider for another random number. Let's consider 15, and then we consider n minus 1 15 as 1 0, see, 1 1 1 0, right? This is 1, bad, this is 1. Now we need to perform AND operation over here. We'll get 1 1 1 and 0. See, the thing is, when we perform this AND operation, it just give the number of counts. My bad. So it's going to simply turn over, just it gives you simply number of count. If we have, let's consider in this way, let's put it in this way, n and n minus 1 you have, right? So to count the number of ones, so we need, for 8, it is counting 1 time. That means we are just checking the power of 2. I mean, in the power of 2, in that way we are just checking the number of bits. So similarly, in this Brian Kerrigan's algorithm, so what we supposed to do is, we supposed to check n and n minus 1, and then we need to supposed to check the count. That means we're just simply performing, I mean we're just simply checking at each position, at each power, whether we'll be having 1 or not, and then we just putting that number into n. I think you got my point. And then we're just incrementing the count, and then while n is greater than 0, we're just giving the answer. Now next last method is inbuilt function. We don't have inbuilt functions for C and Java, but we have a built-in function for C++ and Python. You can use it. So first, what we're supposed to do is, first in C++ we need to underscore built-in underscore spot count, and just we need to directly write it, and it gives you number of count bits, count set bits in particular number. In Python we need to convert that into binary number first, and then we need to supposed to count 1. I think you'll be showing some love. Until then, take care, bye bye.